equations, we're solving equations that have the absolute value bars in there. Now remember, when we take the absolute value, the result is always what? Positive. Okay? That's really, really important. That absolute value always gives us something that's positive. So we have this rule about solving equations in the form absolute value of x equals a. If a is positive, what we can do is we can take it and write it as two separate equations. One where a stays positive, one where a becomes negative, and then we just get rid of the absolute value bars. So I want you to think about this. If I take the absolute value of 5, what do I get? 5. If I take the absolute value of negative 5, what do I get? 5. I have two numbers that give me the same absolute value, which is why when we take absolute value, I can write it as two equations because I have two values that will give me that same result. So, let's apply that. Well, we just did this. If I take the absolute value of p, I get 5. What can p be so that when I take the absolute value, I get 5? Negative 5 and 5. I have two different options. P can be 5 and p can be negative 5. So fundamentally, that's what we're doing. We're trying to figure out what can I have inside my absolute value bars that will give me that absolute value. Most of the time, there's two options, a 5 and a negative 5. Now here, I have a lot more than just a variable. I've got an expression. But what we're saying is that the absolute value of this has to give me 4. Well, there's two numbers that give me an absolute value of 4. What? What two numbers give me an absolute value of 4? Negative 4 and 4. So this has to equal 4, and it also has to equal negative 4. It has to be both, because both 4 and negative 4 will give me an absolute value of 4. So I need to figure out what value for n will change that entire expression to be a 4 or a negative 4. And then we solve. We subtract 6. Just doing both equations simultaneously. 2n equals negative 2. And then 2n equals negative 10. Divide. N equals negative 1. And n equals negative 5. So I'm going to have two answers. Again, if n was 1, or if n was negative 1, or if n was negative 5, both of those will give me an absolute value of 4. They'll both work. Now, this will be the number one most common mistake made from here until the end of time, as far as absolute values. Notice that our rule in the beginning, it's just an absolute value that equals something, right? There's nothing else there. Do I have an absolute value that equals something? No, I don't. I have an absolute value minus something that equals something. You have to get the absolute value by itself first before you do anything else. Because the rule is the absolute value of x equals a. If a is positive, then we can split it. But I don't have just that. I have this extra stuff. Well, let's move that extra stuff. I'll get rid of that negative 6. Add 6 to both sides. So now I have the absolute value of 2x equals 10. Okay? So now I have an absolute value equals something. So now I can go ahead and use that rule and split it. So this has to either equal 10 or negative 10. So I can write it as 10, and I can write it as negative 10. Well, solve for x. 5 and negative 5. But you have to get the absolute value isolated first. If you don't, you will get a completely different answer. be, here's my work. Why? You didn't get your absolute value by yourself. I saw it 5 times today. It's the most common mistake. You have to remember to do the absolute value bars. Get it by itself first before you move on. Now, most of the time we get 2 answers. All right? But 0 doesn't have a positive and a negative. Remember that this is saying, okay, whatever's in this chunk, take the absolute value. The absolute value is distance from 0. Well, how far away is 0 from 0? 0. So this is the only time that we're going to get one answer is if our absolute value is set equal to 0. If that's the case, we're only going to get one answer. 7x equals 0. So, well, what is x then? 0. Now, just because your absolute value is set equal to 0 doesn't mean your variable is 0. Let's say I had x minus 7 equals 0. It's not going to be 0 anymore. I still have the same idea. It's still only going to be one answer. But there's just one answer. 7. That's it. Okay? So if your absolute value is set equal to 0, you're only going to get one answer. Okay? Now, get your absolute value by itself first. It's always going to be your first step. So let's take a break here. So I have the absolute value of 3z minus 2 equals negative 7. Okay? So I have to figure out what the absolute value is that would give me negative 7. All right? What's the absolute value of 7? What's the absolute value of negative 7? Then how can I get my absolute value to equal negative 7? You can't. No solution. If you get your absolute value isolated, if your absolute value is isolated and it's set equal to a negative, then that's the only time you're going to get no solution. I want to go back and emphasize something very important right here in the very definition. If A is positive. Well, over here, A is not positive. I can't do anything. There's no way you can take an absolute value and end up with something negative, a solution. But be careful, because sometimes you may see something like this. Okay? Right now, my equation equals negative 4. So the impulse might be to say, oh, it's no solution. I can't get a negative. But you can only make that determination after your absolute value is isolated. Because here, it was set equal to a positive number. But I still end up with no solution. So if I end up adding to both sides, well, now I have a positive number. That has a solution. Because set equal to a positive number. That we can do as normal. 3x minus 2 equals 4. 3x minus 2 equals negative 4. Solve the process. Business as usual. Okay? So that's the quick and dirty absolute value equation. Questions, comments, concerns, queries, or conundrums. So you have